Hello, everyone. This is SIG scheduling meeting on September 18th. And we have a few things in the agenda. I see also a new one, not that. Okay. So today we don't have Kanzi, we don't have Maciej from the SIG leads, but I think we have a lot of people interested in today's discussion. So let's start. Heba.
Hi, as I mentioned, no action is needed. Just wanted to announce that the SIG dashboard is ready to use. So sorry for adding my action in the front, but I just wanted to let you know in case you wanted to use it since, like starting this meeting. That's it.
All right. So maybe do you want to start? But I think we may review first.
I thought like Kendi and other folks reviewed it because they closed the issue.
Yeah. Review in a sense, if we want to go through the enhancements or the ongoing work. So do you want to like maybe share and we can take a look quickly?
Oh, of course. Yeah. I shared this in the chat and asked for requested to be able to share.
Okay. Okay, I think you should be able now to share.
Okay. Yes. All right. Let me know when you can see it.
Yeah, we can.
So basically, there was an issue in the Kubernetes community to enhance the way we're managing our enhancement and the issues for each release and the backlog and everything. So since we already have a dashboard, I have been working in the past with the previous leads to have a dashboard, but it wasn't well maintained since then. So I just added some or updated it a little bit. So for now, everyone can see it. The leads and maintainers can edit the dashboard. And basically, it has a couple of views. The most important ones are the release, which will include everything like with a tag or a release 1.35, and of course it will get updated every release automatically. So in that case, we will be able to see the like everything we have, if we need to triage anything, or like the progress. Another important tab, which we, like the maintainers and the leads asked for it, which is the PR reviews. They wanted to have a way to know who is reviewing which PR or like which enhancement. So I added this view here and added all the maintainers, or we can add more. Anyone who is willing to review a specific enhancement or assign, like be assigned to review specific enhancement or a specific PR from the SIG leads, we can check the name here, and we can, of course, filter by this name, so we can know who is reviewing what. And yeah, the other views, basically just to be able to see all the enhancement we have, what is the status for it, do we need to triage anything, what is in the backlog stuff, and everything like that. Same thing for the issues and PRs. And I specified the priority, which all the issues and PRs with priority important in a separate tab, because this was another request or another requirement. So yeah, I think hopefully this will help now to know everything we have, and we can start to use it or utilize it for this release to know who is doing what. That's it.
Oh, that's great. Thank you.
Sure.
All right, so let's get back to the agenda. So I think the next thing we had is working group checkpoint restore. Okay, so Victoria or the others.
Yeah, hi. So I will present. Can I maybe share my screen?
Yes. Okay.
I need to find it. How can I share the screen? I don't see it.
You should be able to. At the bottom, you have
I see it now. Mhm. I need to quit and reopen Zoom. I didn't expect this.
or you can tell me, I can share something.
Okay, so
Do you want to share the charter, maybe?
maybe just open the presentation.
Okay, which exactly presentation?
Yeah, I shared it in the chat. Maybe you see it. I don't know. Let me just like quickly rejoin. It will be very quick.
Okay. Just in case, I think I have it.
And now it says that I am screen sharing. So I don't know.
Okay,
Yeah,
the
we can see
presentation is
it.
short.
Okay.
So.
Okay, this was weird. Sorry. Okay, so I would like to introduce you to working group checkpoint restore. We are working on this with Radostin, he is present here, and Adrian Reber. So just formally, the checkpoint restore has been introduced into Kubernetes as forensic container checkpointing, which is now available as a feature. And from there, we moved to enabling, or we would like to move to enabling a general checkpoint restore in Kubernetes. There is an open CAP in SIG API regarding creation of checkpoint restore API in Kubernetes, and there is like quite or more extensive README than in the working group checkpoint restore, so there are more user stories. And recently we have also created a pull request for the working group itself, and there are a couple of stakeholders. So Radostin has presented the working group on Tuesday in SIG Note, and now we are here and we will move across other. So for anyone who doesn't know, this is the bad quality picture that shows how checkpoint restore is integrated into Kubernetes. So we need a specific tool called Crew installed on a physical node, which itself performs checkpoint restore. And then there are bindings in a container runtime, such as containerd or cryo. And then there are bindings in kubelet. And then we would also like to have bindings in the API. And this whole interaction till kubelet is already now or already done. So this checkpointing already works together with restore. And there are like multiple use cases where we can utilize checkpoint restore. We usually present all of these, such as infrastructure level fault tolerance. It seems I miss something here, but we can imagine it as when you have a very long running job and just want to periodically checkpoint it, just provide the fault tolerance. Then we can use this for optimizing resource utilization, something alongside preemptive scheduling with checkpoint and restore. It is possible to reschedule workloads, maybe according to some better schedule or to decrease fragmentation, or maybe to provide a better node for a workload. We can also do some preemption in favor of other workload. An example would be to preempt some long-running workload in favor of interactive one during working hours. Another use case is load balancing, so live migration, then the forensic analysis, which is the original use case, and also the warm container startup, which is useful for serverless workloads or for machine learning inference for like hosting models. This is the current state of checkpoint restore in Kubernetes generally. So what works is checkpoint restore for CPU and GPU workloads for both AMD and NVIDIA. And the checkpoint is fully transparent. There is no API interception in the case of the GPU. Then in the phase one of the working group work, we would like to enable pod level checkpointing, like on the
Vicky,
full pod level.
maybe Vicky,
Yes.
I think Dominic has his hand raised.
Yeah.
Sorry.
Yeah, I just wanted to ask the forensic use case. How is it different from all the other use cases?
Well, in the forensic use case, the workload is just checkpointed, but keeps on running, and it's used for like security analysis, let's say. But in the case of, for example, preemptive checkpointing, you would checkpoint the workload and do not keep it running. You would like the container is basically killed and not resumed. So that's the difference.
Can I add something? So I guess we decided, so we discussed with the Kubernetes community how to enable checkpointing at the beginning, and we chose to use forensic checkpointing because essentially it simplifies the implementation. So for essentially our use case is if you have a cyber attack and if the attacker has been able to gain access to a container, we can create a snapshot of this container, and then we can use the snapshot to analyze what the attacker has been doing. So this use case requires only the checkpointing functionality. It doesn't require the restore functionality. And we implemented a tool that allows us to analyze the checkpoint.
Yeah, thank you. That clarifies.
Vicky, sorry for interrupting.
Yeah, that's fine. So this is like the phase one, the first things we need to do, and then any subsequent phases that would come would be regarding various areas of checkpoint restore where we think there might be some like changes needed or some more features, such as in the security, the encryption of the checkpoint itself, or in the Kubernetes ecosystem, who can even perform checkpoint if it's like only administrators or also users, or it's like airbag based. Then regarding storage, so one ongoing discussion is the checkpoint format, because it is not the most optimal right now, and it takes some time to create the checkpoint and then to also transfer the checkpoint. Then there are some areas to solve in the networking, such as preserving the pod IP address. Then regarding resource quotas and namespace quotas and maybe limit ranges. So many other aspects to solve. And that's what I already said, that the working group was discussed on Tuesday in SIG Node, and the attendees kind of agreed that we need a proper checkpoint API. And we also had a quite extensive discussion about priorities. There was also one suggestion about like CRI image service extension for prioritized and possible image pools. And from there, we had a discussion about priorities also regarding to scheduling, such as like if you preempt a workload, then if its priority is inherently increased because it was preempted and you need to eventually finish the workload. We also presented working group at the meeting of working group Node Lifecycle, from which Philip is present here. And they are currently drafting eviction request. And I think that checkpoint could be also used under the eviction request in some cases, such as when you are draining a node and there is a workload running that has a high cost, let's say. Again, it could be some long running workload. And maybe there is also some relation to workload aware scheduling, but I don't know yet since it's only a draft. And these are like my questions on the scheduling community regarding checkpoint restore and what we might be missing and what needs to be solved. So generally, the questions I have is that, as I already said, if we checkpoint the workload, if its priority is then increased, or if it's or if it doesn't change, because it could be possible that this workload would never be finished. Related to that is if such restoration is automatically managed by scheduler, or like a user or administrator, doesn't matter, always has to trigger the restoration manually. I don't know, it's open for discussion. Then also, if like the priority of the workload should be as with the priority classes, or it should be more workload aware, such as, okay, this was this type of a job, maybe it's more important. This is another type of a job, it might be less important. And the third bullet point is just like related to first one, but the fourth one is also quite interesting to me because I don't know. Container checkpointing can take some time, and imagine you have a situation when you are preempting some workload for some higher priority workload or maybe some interactive workload, and the checkpointing can take some time. And I don't know if, for example, reserve phase of scheduling or pre-bind or bind phase of the scheduling can just time out while waiting for the container to be created. So, and this is also something I would like to know if you know.
Mm-hmm. So, first of all, I definitely think that this is related to workload aware scheduling. directly or indirectly, because of course the workload level preemption is in scope of that effort, and having ability to checkpoint and preempt workloads which otherwise would be completely lost is definitely a value. The question is whether the time that needs that the checkpointing requires, it's something that can be predicted upfront, or is it something that varies a lot?
Yeah, so it depends on the size. For example, it depends how much memory we're checkpointing, and it also depends what time. Yeah, it varies both over time for specific workloads and across different workloads. So we can, we can use some heuristics and try to estimate some time, but it's a complex problem. It's not easy to solve.
Sure, but that would be very helpful in assessing like which operation is cheaper, whether to
Yes.
checkpoint
So,
and
Vicky.
Yeah, so I just wanted to say that we published a paper on checkpointing or on scheduling with checkpoint restore in Kubernetes, and we did like a very simple test with checkpointing something that occupied a lot of memory, and then some other workload which didn't occupy a lot of memory, but it was a Linux kernel antar operation which extracted a lot of files into the files overlay file system. And they took roughly the same time because the operation, there have been a lot of changes in the overlay file system that had to be checkpointed too, and that equaled the time to checkpoint the memory of another workload. So this kind of illustrates that it also depends on what it is. If you would have a workload that just occupies a lot of memory, but also has done a lot of changes in the file system, it might be possible that it's not really feasible to checkpoint such workload. It would just like kill it because it would take too much time. And I personally think that it would be possible to maybe create some analysis and create some heuristics, as Radostin said, but I don't know if it would be really smart to always base the decision on this because it depends.
Okay. So we definitely were thinking about having timeouts for different scheduling phases, and preemption is one of those which we basically have to time out at some point. But
I think just to add something here, so one of the main use cases is, for example, if you have a long running job, something that runs for weeks or months, essentially you want to periodically create a checkpoint, and then if something happens, you want to restart from the last checkpoint. This is one of our use cases.
That would be also useful. So that means that basically we could stop the workload and restore it from the last checkpoint.
Another one is when, for example, you want to perform maintenance for a specific node and you want to migrate the pods from one node to another. This is where we can also checkpoint the pod and then restore it from this checkpoint. Eric?
Yeah, don't most high performance computing jobs have application mediated checkpointing? And like, why wouldn't the CREU functionality be like surfaced to the application so that it can initiate checkpointing if that's how it wants to do it, rather than having the scheduler Kubernetes system initiate it?
Also, it's not true that like many applications have the checkpointing functionality. So in our clusters, we run a lot of containerized HPC applications. And if someone in the past had not implemented such checkpoint, which is really scarce because it's hard to implement it and you need to evolve it over time, then you basically don't have any application checkpoint. And there are many HPC applications like that. And this is like fully transparent to whole container. You don't need to anyhow change the application itself. So it's reasonable to use this for applications that are different from, let's say, I think that some machine learning frameworks do provide checkpointing functionality, which I think saves like weights and some computed stuff like that. So there it might make sense to just resume it from this checkpoint, but I believe that there is some state also computed in the memory and it might take like a lot of time to again restore it. That's where this transparent crew provided checkpoint comes into play, where you just like take it as a whole and dump it, and that might save you the restoration from the beginning, even if you have the weights. It's true that we cannot say sometimes in advance what would be more efficient. There would have to be some like analysis done. Maybe we would see that sometimes it's not efficient to create a crew checkpoint. And why scheduler would have to do it? Well, because like scheduler knows what is running where, and when you administer a new workload and it passes all the admission webhooks and everything, then you can come to the point where like the scheduling takes place, and if the workload cannot be accommodated, then also like preemption can take place, and that's what the scheduler does.
I mean, the application receives termination notice if it's going to be preempted. So it could wrap the command in a handler, which is a popular pattern that receives the preemption notice and then triggers the crew checkpointing from the container. So that's another design pattern to consider.
Right, but I think what's important is that schedulers should know that the application is capable to do checkpointing.
Yes, whether the
would be
scheduler should
valid.
know about both crew and application level capable checkpointing applications. Agreed.
Yes, and just to add to what Eric said, so we discussed this actually on Tuesday, exactly the same question that you asked. So it is very useful, for example, for training jobs to be able to the application to trigger the checkpointing, for example, at the end of the epoch. And this is something that several people have asked and suggested that it's a useful feature to have, and something that we're going to discuss in the group, in the working group. Amy?
Yeah, this seems really useful. Like besides like triggering the checkpoint, it also seems like it'd be useful to affect scheduling in that if it has recently checkpointed, it's a more likely candidate for preemption. Whereas if it's been a longer time since the last checkpoint, perhaps it could be like it's less likely to be preempted, although that seems also kind of hairy, but I just haven't really thought about this domain that much. But yeah, like it seems really useful for like a training context.
Yeah, so you are right with the idea. Actually, there exists quite some body of work from the past regarding preemption-based checkpointing, where people suggest the same things you say, that maybe we should take into account the time from last checkpoint, or how long is this running, or if this workload requires a lot of resources or just small amount of resources because it will be checkpointed faster, or if it's on some kind of node, or if is the workload is of some user, but that is already starting to become very complex.
So where did that conversation direction go? Like, was it a bad idea or was it
No,
something being
it was a
considered?
good idea.
Oh, okay. Yeah, I couldn't tell because yeah, I just haven't thought about the domain. Like if it was, I don't know, like if it made scheduling too complicated somehow. But yeah, it sounds really interesting. I'll definitely take a look.
Eric? Oh, Philip, actually, sorry.
I think I was second, sorry.
Okay, so Eric.
So right now, applications don't have an incentive to set a tight like termination grace period. But if you knew that some applications could terminate quickly, either because they're able to checkpoint or because they just are like willing to be terminated quickly, then you can start thinking about doing backfill scheduling, like where you like try to sync, like if you're preempting multiple things, you try to like synchronize them, and then maybe you have some gaps, then you fill that in with applications that you know that can both start and end within a bounded amount of time. So I think that's an important area for the scheduler to think about. We need to create an incentive for users to like accurately estimate their preemption time. And I think that can be dynamic when you sort of bring in like checkpointing, recency, and cost. So that's how I frame the problem.
Yeah, so this is a difference from batch scheduling systems that do these backfilling algorithms, where they often take into account the estimated runtime of the job that the user provides, and based on this time, they do a lot of optimizations of like who is backfilled and stuff like that. But since in Kubernetes we don't provide any runtime to the pods or jobs or any of these deployment types, I was also thinking about what would be the criteria to optimize for, and I didn't think that we would want to add something like I am willing to be checkpointed and this is my checkpoint time, because this would be really useful and this would help us a lot in estimating and creating some scheduling decisions.
Yeah, I think applications, some workload types and pods do have like maximum runtimes on them, but it's not in Kubernetes, but it's not used in an organized fashion. And it's not clear how that maximum runtime relates to the grace period either. So I don't think the scheduler today can like reason about, if I start this pod, I will definitely get these resources back by this time. I think in systems like Slurm, like they pretty rigidly enforce the runtime, and the cleanup time is like bounded and it knows what it is. So that's a pretty big difference between us and those systems.
Mm-hmm. Philip?
Yeah, I think there could be a way for like preemption to use eviction requests. So like basically we are thinking of adding like eviction interceptors to the pod, like as a field. And then like you could actually see which pod has the like if the like the checkpointing, if it would add an interceptor to the pod, you could actually see which pods have the availability to checkpoint. And then like during preemption, we could create this eviction request, and then like this could be used to communicate the information about the checkpointing, for example, because it basically it doesn't terminate the pod like immediately. So you have like some time to get some communication from some controller that could maybe tell you like how much time it would take for the checkpointing, and or like have a back and forth between the scheduler or the preemption logic and the checkpointing controller.
One thing that is very important when estimating the time is how long does it take to write to disk. So essentially, when you write 100 gigabytes, for example, it depends how fast is the disk.
Yeah, but maybe such eviction requests could at least signalize the willingness of the workload to be checkpointed in case it is needed, so that maybe such workload can be preferred for preemption and not another one. If this workload shows that, okay, I am fine with being checkpointed. The other the other thing I was thinking about is that I guess no one would be really willing to be checkpointed unless they receive some reward for that. Because I can't imagine which user would be fine with delaying the finalization of.
Oh, the risk of preemption is already convincing.
The reward is usually that there's a multiple queues in the queuing system, and one of the queues is shorter, but it requires that you like accept this. And so when users submit their jobs, if they're willing to submit to this shorter but more restrictive queue, then they get a lower time waiting before their job completes.
Yeah, but
So
then I guess maybe like backup period should be different. If you are willing to be checkpointed, then maybe you are then retried, I don't know, faster or something like that.
So we have more topics in the agenda, but really quickly to summarize. So are we saying that we can have two different approaches? The one is the application level checkpointing, which would be surfaced to the pod API or workload API in some way, and checkpointing which can work and be initiated from the framework side and would work on any pod, any workload. So do you consider both approaches?
Yeah, this one we are focused on the transparent one, so that the one that works for every workload, and the workload does not have to advertise about itself. It's able to perform checkpoint.
But I guess like the extension and the API could be the same, because it's just a matter who triggers the this checkpointing and performs the checkpointing.
Yeah, like regarding scheduling, yes, it doesn't really matter. If the application says it has some form of checkpoint, then whatever, it can be killed. It said it has a checkpoint, so.
Just to add that essentially this is a new working group, and we're looking mainly for feedback on the use cases that essentially we want to kind of introduce the working group and ask for feedback on the use cases that we are considering.
Okay. All right. So is there any other question? So I think we can move to next topics. So we can have a follow-up on the gang scheduling API proposal. I wonder if there are any topics for discussion. From the ones that I see is that like we had a discussion about that, and we believe that going forward with Eric proposals makes a lot of sense. Even if we make some wrong decisions, we can always like reiterate. So we think about introducing the API for alpha, and actually we also try to provide a very simple implementation that we could finish for the 135 release, so which could simply bring a value pretty quickly. So we have two documents now. We have the API proposal and a separate one about how we think it could be implemented in Kube Scheduler, which I shared like an hour before the meeting. So probably you haven't had chance to read it yet. So the question is whether we want to follow up on the API or jump into the implementation, how we think it could work. Eric, do you want to add something regarding the API discussions that were in the doc?
It seems to have had good reception. There's kind of two little naming issues that I called out in the CAP as unresolved, and it's much more succinct to read where we're at in the CAP pull request that I just submitted. So
Yeah, I forgot to mention.
Take a look at that afterwards and comment if you have thoughts.
Yeah, I forgot to mention that we also Eric just shared the cap proposal. The cap that would be, we think that it will be the only cap, and the implementation details will be the eventually part of this cap. So the discussion may be either in the document or in the final cap. Probably the document will have more details than the cap, so feel free to choose. Eba?
Yeah, just to clarify, the cap will be for the API only, and the document is like the general problem, and we will keep working on this document, or what, like I'm a little bit confused.
Not really. So there will be cap that covers content of both documents. So both the API and the implementation.
Okay, so the KIP is just a placeholder for now, but everything in this document will be added to the KIP. Is that right?
The documents consider alternatives, and the KEP says what we're doing. So the API design doc is summarized there very succinctly. And then the gang scheduling for alpha proposal is also very succinctly summarized, and we'll probably add a little bit more detail in there. But the KEP will cover both the API and the scheduler internals succinctly.
Okay, yes. Thank you.
So are there any questions regarding the API? If not, I could present briefly what is in the how we imagine the implementation. So let me open that now. Right. So the motivation is basically what I said. We think that it's worth to go ahead and have some basic implementation of gang scheduling in the kube scheduler. So the implementation will not change much the kube scheduler. The pod by pod scheduling will remain mostly the same like it is today. So the things that we will actually implement is gating pods on the wait on permit gate, and before pods enter the scheduler on pre-enqueue. So from the API, we will mainly take two things: the min count, so the minimum number of pods that a gang is expecting to have, and the scheduling timeout. So the sunny day scenario is pretty straightforward. So the pre-enqueue will wait until all the minimum number of pods appears and is visible to the scheduler. And also we expect the workload object, which describes the gang, to be present as well. And in the framework, we'll capture both of those objects and we'll create a internal structure that will represent the assignments of pods to gang. And pods will be released to the scheduling cycles once, of course, the minimum number of them are waiting on pre-enqueue. And the similar thing will happen that those pods will be gated on wait on permit gate until minimum number of them or expected number of them are assumed. By assumed, I mean the assumption of concept that we have in scheduler, which means that that the pod is basically scheduled, but only in memory of scheduler. I think it's worth to mention. Oh, okay, and of course, if we have the sufficient number of pods waiting, then we ungate and let them go into the binding phase, which is completely asynchronous. And what's important for alpha, we don't expect them to finish successfully, because we will not like observe whether the minimum number of them got really assigned to nodes. But this is a simplification for alpha. It's different if we talk about the scheduling loop. In scheduling loop, the pods that will wait on permit are expected to be scheduled within a timeout. And if the expected number of pods is not scheduled, then we will reject those pods and they will come back to the scheduling queue. So this way we can at least mitigate the problem of deadlocks if we have when we have two workloads which compete for the same resources, and they of course can run into deadlock because one will be waiting for another and none of them can actually finish successfully. So that's the main idea. There's a lot of things we could talk and follow on. Please read the doc, or you can ask questions now. Okay, I didn't hear any. So one more thing I can add is that at least I believe that the actual gang scheduling that we want to eventually have should happen in one scheduling cycle. And there are a few reasons for that. Of course, the one is that we want to make it as efficient process as possible. So processing pod by pod is probably too slow if we want to engage the whole framework to go back and forth and try to find the best placements. That's of course one of possible implementations as well, but we believe that sharing the filtering results among all those pods would be very, very useful, or considering many different placements, assuming that the cluster state doesn't change. That's why it's valuable to do it in a single scheduling cycle when we have the assumption that scheduler is not observing any changes that can influence this process. So we also are working and thinking about whether we can do such a grouping of similar pods and doing more things in one scheduling cycle. But there is a work in progress, and I think we will come back to it later if we have some interesting results to share. So feel free to comment, ask questions, and hopefully we will proceed with implementation this release cycle and agree on the details. Philip?
Yeah, I'm looking at the API and I'm just one question. Like I remember you said this should be used as an opt-in for workloads that want to gang schedule. But to me it seems like when you create an API called workload, that it could potentially be used even for like other things than gang scheduling. And I see like that when you have the pod groups, like the gang scheduling is like by default. So like what is the plan for this API like in the future?
I can take that if you want.
Sure.
I do think that one possible outcome might be in the future that basically all true workloads create a workload object automatically. That would probably be that'd be in the somewhat distant future. We talked about so you can think like a deployment probably wouldn't need gang scheduling, but if we might be able to enable better scheduling features if it scales up quickly and you tell the scheduler that these pods are guaranteed to be identical, or maybe you can reserve space kind of in a buffers way by saying what the maximum number of pods you plan to create is. So I think you could hang a lot of scheduling policy here. My thought was that as you add new scheduling policies to the workload object, those workloads that find it useful will start creating them. Now, we could get to a point where it's popular enough that someone on the UX side says, hey, I want everyone to have one so that I can use it to just do kubectl get workloads and have that be like a generic workload list. I think that's a good conversation to have, but let's get gang scheduling working before we have that. That was my thinking.
Yeah, I understand it comes first. Just wondering about if it makes sense to make it a default. And yeah, I suppose if you have workloads creating these objects, they will probably, well, the controllers or the users, they will probably know what they want. So I guess they will have to choose some scheduling preferences. But yeah.
I mean, if you wanted everything to have a workload, you could have an emission controller that finds stuff without them and makes sort of empty, unopinionated ones. I don't know how useful that is to have a bunch of empty workload objects around, other than that you can list them.
Philip, you were asking if gang scheduling should be the default for those gangs, or if that should be
flat. It's just I'm just wondering about the future proofing of this API.
Yeah, I think this is an alpha, and we need to figure those things out. But we have a pretty high degree of flexibility to change things in alphas if we make multiple alphas. So there's a lot of policies we can tie on that. There's a lot of we've talked about topology layering, like the infrastructure topology, aware scheduling being layered on top of that. So I think there's a lot we can do.
Right. You might have a deployment, we might do a version 2 of topology spread constraints where it's specified in the workload instead of the pod. That might be easier to implement. At which point now you say, well, deployments are going to want to have this because they want to have spreading. So my prediction is that this is successful. All workloads will have one. And there's a bunch of discussion in the really long, document about the API that kind of touches on a bunch of these points, if you're really curious. Also happy to chat.
I think you can correct me if I'm wrong, but the pod groups are optional in workload. You don't have to use them, right?
Correct. I think even for alpha, we could make it valid to create a workload with a zero length list of pod groups and attach it to any workload you want. Open to thoughts on if that's useful to support,
Right. We also had idea of creating workload by default in scheduler for at least any true workload that enters scheduling. That was the idea floating around, and we could figure out like which pod potentially form a gang. So we could do some defaulting in some of the places to at least increase the how workloads are used. But definitely, it should not be mandatory to use gang scheduling for any kind of workload that we are thinking of. So it should be future-proof. But one more thing I wanted to say, if we think about workload-aware scheduling, and so having an ability to schedule a workload in one scheduling cycle doesn't mean that we have to have pod groups there. We still can do that, especially if we need to reschedule workloads. Reschedule, I mean, find a different place for things that are already working and running. Doing in one cycle doesn't imply the pods have to move as a gang, but we still can think about rescheduling in one cycle. That would be something that we can do on a workload level, not necessarily on a particular gang level.
Another way this, sorry, can't talk.
All right.
Yeah, I just want to conclude. I understand like it's better to do the rollout of the feature slower, like to just what we need. For example, the gang scheduling and for the workloads we need. And like from what I understood before, you said like you are not rushing with the evolution of the API, right? So you maybe will have like multiple alphas or until you get the API where you want it.
Yeah, I think so. We are open for evolving in the iterative manner. But I think whenever you have some specific concerns about the API proposal, I think that's the right time to raise them in the document so that we can discuss them. So do you see any parts that are suspected to not be a future proof?
Yeah, just this thing. Yeah, I have not read the cap fully, so I will give it a better look.
Yeah.
Another way that you could use workload with other types of true workloads. I think one of the problems today is that, especially with custom workloads, when the scheduler finds like a pod is unschedulable, it sets that event on the pod, but it's not summarized automatically to the workload. We could in the future change the scheduler that if there is a workload to like send events on the workload, and then it'd be easier for the user to see aggregated view of scheduler events across large workloads. Right now, it's like a multi-step process to like dive in, why is my workload not working? And then like, let me go look at all the pods to try to find relevant events.
Yeah, that sounds interesting.
Yeah. I think we are over time, so we probably should wrap up. So any other questions? If not, then please comment in the documents or whatever thoughts you have. It will be super helpful. So thank you everyone for the meeting, and see you the next time. Bye.
Bye.